there is a very strange object flying past our sun right now. We don't exactly know what this thing is or where it came from. We can't even see it anymore. But we have been watching this object very closely for months. We've given it a name, 3I Atlas, and we've given it a title, Interstellar Comet. In just 4 months, there have been nearly 100 research papers published on 3I Atlas. Some of the findings can sound pretty insane, so today we're cutting through the noise and getting to the bottom of everything you actually need to know about this mysterious visitor. Let's start with how we found it. We've been tracking 3I Atlas since July 2025. It was officially spotted by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is a network of telescopes scattered around the world in places like Hawaii, Chile, and South Africa. These telescopes stare at the night sky looking for moving objects, and that is what they saw on the night of July 1st, just another moving object. So they classify it as a new asteroid and prepare to move on. But then they notice something weird. It's moving too fast. Everything in space is constantly in motion. Every object in the solar system rotates around the sun because we are all trapped by its gravity. But if you move fast enough, you break free completely of the sun's gravity and fly out into interstellar space. You enter the void of nothingness that exists between stars. When astronomers clocked the velocity of this new object, they were shocked. This was the fastest moving object ever detected in our solar system. Let's establish some scale. Earth orbits the sun at 30 kilometers per second. Mercury, much closer to the sun, has to move at 48 kilometers per second to avoid falling into the gravity well. The new object, discovered by Atlas, was moving at 58 kilometers per second. And it was still way out there, just inside the orbit of Jupiter, about 4.5 astronomical units from the sun. At that speed, it was clear this object was going to blow straight past the sun and keep going. We call this a hyperbolic trajectory. This thing came from interstellar space, and that's where it was returning. This is when the name 3I Atlas came to be, Third Interstellar Object, which means there were 2 before it. You probably know the first one, Oumuamua, the first ever identified interstellar visitor. It was weird in its own way, cigar-shaped and tumbling through space in a way we still don't fully understand. Then came 2I Borisov, the often overlooked middle child. It was actually not that weird. Aside from being interstellar, it basically acted like a normal comet. But 3I Atlas is different in 3 major ways. First, size. Oumuamua was up to 400 meters across. Borisov was about 1 kilometer wide. But 3I Atlas could be up to 5.6 kilometers in width. It's literally much bigger. Second, speed. Atlas travels at about double the velocity of its interstellar siblings. And third, the direction it came from. This is the really weird one. Oumuamua came from above, from the northern sky, which is the general direction our solar system is moving. So we kind of ran into each other. Borisov did mostly the same thing, but 3I Atlas didn't come head-on. This one is a T-bone collision, coming in at a side angle in almost perfect alignment with all the planets. Our solar system is like a flat disk of stuff that all formed around the sun. We call that disk the plane of the ecliptic. Everything from Mercury to Neptune orbits in roughly the same flat plane. There are only a few things offset from that plane. Pluto's orbit is tilted by 17 degrees, so sometimes it's above the plane and sometimes below. But 3I Atlas? It's only 3 degrees off from that ecliptic plane. It hit our solar system in near perfect alignment with the disk. Space is 3-dimensional. That object could have come from any direction. To have something hit us almost perfectly side-on is a massive coincidence. So where did it come from? We know it came from the direction of the galactic core, from the bright center of the Milky Way where stars are packed much tighter than in our neighborhood. But astronomers believe it actually originated from an area called the thick disk, a region above and below the main galactic plane. It's less crowded there, so objects hang out undisturbed for very long periods of time. This could make 3I Atlas as old as 7.6 billion years, nearly twice the age of Earth. Astronomers have managed to backtrack the object's journey over 10 million years. They've identified 93 stars it would have encountered during that time. But here's the fascinating part. The closest it came to any of those stars was 0.3 light-years away. That's 63,000 astronomical units. Right now, it's just 1.4 AU from our sun. Even though 3I Atlas was officially discovered in July, it was actually first spotted on May 7, 2025, by the Transiting Exoplanet Survey Satellite, or TESS. This observatory happened to be looking in the right direction for about a month, giving us a chance to track the object as it moved through Jupiter's orbit. The first thing astronomers measured was brightness. How bright an object appears tells us what it's made of. During that month, 3I Atlas traveled about 1 AU closer to the sun, Astronomers expected its brightness, what we call flux, to increase by a factor of 1.5, but it increased by a factor of 5. That massive jump in reflected light told us this wasn't an asteroid, it was a comet beginning to form its coma, that fuzzy cloud of gas and dust that reflects sunlight. But there were two weird things about this. First, the light polarization was completely wrong. When sunlight hits the coma, it scatters in specific directions based on what the material is made of. Most objects in space, including the previous interstellar comet Borisov, show positive polarization, but 3I Atlas shows negative polarization. And not just negative, but the most extreme negative polarization of any object ever discovered. This tells us that not all solar systems are the same. What's normal here is weird somewhere else, and what's normal elsewhere is weird to us. The second weird thing was that the coma existed at all. Remember, this was May and June. 3I Atlas was still beyond Jupiter's orbit, over 5 AU from the Sun. It's incredibly cold out there. We don't typically see comets form their coma until they're between 3 and 4 AU from the Sun. That's because normal comets are mostly made of water ice, which needs a lot of heat to sublimate. But when we pointed our most powerful telescopes at 3I Atlas, we discovered something shocking. The coma was dominated by CO2 gas, not water. The ratio is about 8:1, CO2 to water. That's basically the inverse of what we find in normal comets. If you've ever seen dry ice, that's frozen CO2. It sublimates instantly when removed from a freezer, creating that signature smoky cloud. That's what 3I Atlas was doing way out in the cold darkness of space. CO2 ice melts at a much lower temperature than water ice, which explains the early coma. But as we continued observing, something changed. By late September, as 3I Atlas passed through Mars's orbit at just over 1.5 AU from the Sun, it suddenly began releasing a massive amount of water vapor. We're talking about the equivalent of a fire hose running at full blast. This was more water than we'd expect from even a normal comet at this distance. We've never seen so much water appear so suddenly. The same bizarre pattern showed up with metals. During the summer, astronomers detected nickel in the coma, but no iron. This is strange because nickel and iron are formed together inside dying stars, then blasted out during supernovas. They're typically found together in planets, asteroids, and comets. So when we see nickel but no iron, we have to wonder, where did the iron go? What process separated them? And it's weird to see any metal sublimating at all when the object is still so far from the Sun. The CO2 release is likely dragging nickel atoms along with it, but that doesn't explain the missing iron. Then, just like with water, iron suddenly appeared in late September. The ratio quickly normalized to what we'd expect. 3I Atlas is becoming more normal over time, but it's getting there in a very strange way. Then there's the tail situation. When we first saw a tail forming around 3I Atlas in the summer, it was pointing in the wrong direction. It was facing toward the Sun. Comet tails are created by solar wind, radiation that flows away from the Sun. So tails should point away from the Sun, not toward it. The likely explanation relates to that early coma formation. Because the object began sublimating so far from the Sun, the solar wind wasn't strong enough yet to push the gas and dust away. Instead, the material accumulated on the warm sun-facing side. Eventually, as it got closer, a normal fan-shaped tail formed pointing away from the Sun. On October 3rd, 3I Atlas passed within 0.19 AU of Mars, the closest it will come to any planet in the solar system. Lucky for us, we have cameras on and around Mars. The Perseverance rover captured images from the surface, though they're not great. The rover's camera wasn't designed for this, requiring 30-second exposures that were stacked together, creating more of a streak than a defined object. The European Space Agency's ExoMars probe got a clearer view from orbit, but still not enough resolution to distinguish the surface from the bright coma. As of October 29th, 3I Atlas is making its closest approach to the Sun at 1.4 AU, somewhere just inside Mars's orbit. This is perihelion, the time of peak activity when the most material gets blasted into space. But we can't see it. The Sun's glare completely blocks our view. We'll have to wait until early December when it emerges on the other side. Then we'll see how the Sun changed it. On March 16, 2026, it will make one final close approach to Jupiter at 0.36 AU. The Juno probe will have a chance to capture one last image before 3I Atlas disappears forever into the void. By then it will be cooling down, less active, but possibly transformed by its exposure to our Sun. It's entirely possible that many of these strange characteristics didn't come from where it formed,